right. All right. Hello? Anyone here? All right. Woo! Oh no. What the? Hmm. That's strange. Anyone? All right. Hello? Anyone? Anyone home? Hey, Flacca. How are you? Who is that? Who is that on the icon? Hey, Flacca. All right. You're the first one here. Audio check, mic check, 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 1, 2, check, check. Audio check, video check. Audio check, video check. Need some help. Need someone to chime in. Anyone chime in? Are we on a delay? Thanks. Okay. All right, we're good. Audio check, mic check. Anyone else chime in? Hey, Sky Pencil. How are ya? All right, good. I said yesterday in a presentation to the Tufts faculty, saying, good enough audio and video is not good enough. Hey, Data Guru 18. How are you? How are you? How are you? All right. So, looks like it's been a while. I think it's been like 3 weeks since I've been on. Um, so, hello everyone. I'm Ming Chow, Associate Teaching Professor at Tufts, and we are finally back after it seemed like a mini vacation, although it really wasn't any vacation. There was no spring break for me. And today, what are we going to do? Hey Zen, how are ya? How are ya, Zen? What we're gonna do today is really, really, really bad code and analysis. Yes, we're going to talk about really, really, really bad code and analysis. Okay? So, what we're going to do to start off is, can you all see I have a copy of Visual Studio Code open. I have a folder called Bad Code. Nah, it wasn't so much of a break. Believe us, like, the faculty never gets a break. Yeah, even during, summer's a little bit better. I have a folder called Really Bad Code. Well, bad underscore code on the server. I'll give you the IP later. So, there are 3. I don't care what programming languages you know and love or whatever. Doesn't matter. It doesn't matter what your favorite programming language is. One of the things about security is, we're programming language agnostics. And quite frankly, everyone makes the same mistakes anyway. So, I have a Java program, a JavaScript program, and a C program. What we're going to do is I'm going to open, each of these programs, and you're going to find all the issues and vulnerabilities. Okay? So my first question is, what would you like to see first? The Java program, the JavaScript program, or the C program? Which one do you want to start off with? Your choice. Pick one. Choose one. Java, JavaScript, or C? Okay, Explorer says Java. Song says Java. Anyone else? So we have 2 for Java. Okay, so this is what we're going to do. So I see, it looks like we have a majority for, Java. So we're going to start off, we're going to look at the Java program first. Don't worry about that mentioning of Twit, don't worry about that. Then we're going to look at the C program, and then last but not least, we're actually going to try and break the JavaScript program. All right. So let's take a look at the Java program first, shall we? Really bad code example number 1, twittertest.java. Now, oh, come on, get out. Here it is. That's it. The source code sits on one screen. There you go. Find the vulnerabilities and issues with this code. That's it. I'm not even going to execute the program. There's no need to execute this program. Find all the vulnerabilities and issues with this code. While you're looking at this code, this is one of the biggest differences when you're doing let's say if you're interested in doing cybersecurity analysts or application security jobs. They're probably not going to ask you to code on the whiteboard as they do for the traditional software engineering position, but they're going to show a snippet of code just like this, and you tell me what's wrong. All right, password. Ooh, so think ask. Ooh, hey, okay. So we got SQL injection from a stall feed. Think oscillator actually said password hard coded. SQL injection, password not encrypted. Ooh, okay, what the? Yeah, I stall feed said run as root. Really? Mm-hmm. Come on, keep going, keep going. Believe it or not, there's at least 5 to 6 issues with this code. So far, I've seen 3. So far, I'm hearing 3. The password is weak. Okay. Anything else? Anything? Anyone do Java programming here? Is the name a problem? Perhaps. I think it's okay. Ooh, okay. Flakaba said prints out the exception. Ooh, okay. I think that depending on the error, that could cause more. Okay, perfect. So Zen actually mentioned something. Okay, so let's actually go through what everyone wrote, including the error message response that could cause more hacking. That's all absolutely spot on. Exactly what I was looking for. That's actually what I'm looking for. So let's go all the way back up for a second. So SQL injection. Line number 13. Line number 13 is just a bunch of string concatenation. This is just screaming SQL injection at your face. Okay, this is a 5-alarm fire. Line number 13 that I have highlighted, string concatenation. This line just has SQL injection screaming at you. And what it does, it just can concatenate a string, and the argument arg0 is whatever the user input is. So also, with that being said, there's no sanitization of user input, which also leads up to the SQL injection. So we got SQL injection on line number 13. That's screaming at you. Lines numbers 4 and lines numbers 4 and 5. Let's talk about the vulnerabilities first and how do we resolve the issues. Well, first of all, you got not one, but you have 2 problems here. First of all, you have a hard-coded password. I mean, that's bad. Man, what is it? If you take a look at the CWE Top 25 2022. So you have CWE89 SQL injection. You have a hard-coded credential CWE798. There's a hard-coded credential here. Furthermore, the username is root, and that means you're logging in to the database as root. That means has godlike privileges, super user admin privileges. That's never ever a good thing to actually use root as a user for any system. In fact, a lot of systems, such as Linux now, Linux actually completely got rid of the root user. Okay, that actually an issue. This is going to be, and you can make a case for incorrect default permission 27 CWE 276. Okay, let's take a look. What else? Password is not, yeah, I mean, password hard coded, password not encryption. In this case is like the same thing. Password is weak, okay. Yeah, that's weak. It prints out the exception. This is not good as well. Line number 20. Line number 20 prints out the exception. This is not good. Okay? Why is this a problem? So the reason why this is a problem is, well, first of all, you have two problems. It prints out the exception, which, as Thinkosculator did, no, it was Zen. Zen actually, you wrote, quote, I think sometimes depending on the error message response, that could cause more hacking. Absolutely. You probably saw that in the Capture the Flag game if you played it, or in Damn Vulnerable Web application. This is another one. Okay, so we have too much information, or is that one here? Information. Exposure. You can call this CWE 20 to 200 exposure of sensitive information to an unauthorized actor. You can try that. You can use that as well too. But it's really more information given than necessary. There is also another one. Hold on. Don't know Java, but sounds like you are loading the JDBC driver from a static string field. Yeah, okay. So line number 10. Yeah, this is another one. So this is like, okay, why is the URL hard-coded? Okay. Why is this hard-coded? You can make a case to say, this is the same problem as the hard-coded password. You can make that case as well too. But there's also another one. Shouldn't you just import explicitly? Yeah, shouldn't you just import explicitly? The other one is this. Import java.sql.start. Line number 1. Is that a problem? The answer is yes. What's the asterisk stands for? The asterisk is it's going to load everything in the java.sql library. The problem is that you're importing too much here. You're importing too much stuff that you don't need. Yep. And okay, so a stall for you tried, okay, if they print the class path or something, that's no good. Yeah, I mean, again, that's information exposure. Ideally, if you're going to be importing libraries into any, not only Java, but any programming language, you only have to import what you need, specifically what you need. So you're over importing your stuff. This may cause a performance issue. Line number 1. But I'm surprised. There's also another issue here as well too. I'm actually surprised that no one actually has brought this up. I'll give you an idea. So hold on. I have, I'll give you a hint of what I'm thinking. Line number 10, driver manager.get connection. I'll give you a hint of what I'm thinking. I'm sure each and a lot of you have written a computer program in some sort to open up a file. When you open up a file, what do you have to do at the end? That's a huge hint. There's something badly amiss with this program. Well, one of too many things. Yep, close it. There's no, so when you open a file for reading or writing or both, you have to close it. Same idea when you work with databases. When you open up a database connection, you also have to close it. It does not close automatically. So there is no closing of the database connection. Ah, yes, 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 yes. Try finally. And so I can tell you from personal experience because I wrote Java web apps for a decade, almost 20 years ago. But when I remembered my web app, it was a Java web app. People were connecting to the database, and like every other day, the whole system would go down. There would be a 500 server error saying overload of database connections. And so I was like, what the hell's going on? And try to find out that my web app was creating a lot of database connections in Java, but was never closing them. So there was just a lot of open database connection that just needed to be closed. So that was my fault. Okay. Yeah, does it time out eventually? I'm not, I mean, this was like in the early 2000s. This was in the 2000s. I think it times out now, but yeah, it'll time out eventually. But here's the thing: what happened? You got 2,000 people using the same app at the same time. Well, that's a different matter. Um, yeah, TCP connection will be left open. Yeah, that's also true. So there's a whole litany of issues here. Let's talk about how you now solve these vulnerabilities and issues. Let's start with the biggest ones. It's the SQL injection one here. Line number 13. The SQL string here, that is just based on a string concatenation. Java, the way you solve this problem is don't use string concatenation for SQL query statements. Use a prepared statement that is built into Java. Well, how do you do a prepared statement? Prepared statements. Here we go. So you will need to include java.sql prepared statements. So it will be something like this: prepared statement, connection.prepared statement, your SQL query, but with the value fields bounded by a question mark. So something like this. So that's how you would do prepared statements. Could it print out the structure of the file system? Yeah. Okay, so Explorer 88. Here it is. Can it print out the file system stuff? Yeah. We'll talk about line number 20 as well. So, okay. So how you resolve the SQL injection problem in line number 13? Use prepared statements in Java. Don't do string concatenation. The second thing, well, we have problems 2 and 3. Username is root and the password is HumanHorn, the hard-coded password, and the username is root. So first of all, when you're when you're working with databases, make sure you create a database user account of something else that is not root. Make like another username with some password, and only give that user the permissions that it needs to certain database or database sys. Okay, so does anyone know the formal term for only giving uh, a user the permissions it only needs to do the job? Does anyone know what that formal term is? So I would create a user, let's say, I'll just make something up like, yeah, role-based access, okay. Role-based access is one. So let's say I create a username called Think Oscillator. The password is whatever the password is. By default, you have no permissions. You have access to nothing. I will grant you permission to, in this case, will be the Twitter database. Need to know. or more formally, it's also called the principle of least privilege, POLP, principle of least privilege. This is a document from CloudStrike, also known as Need to Know. No, I'm not going to sign up for your stuff, CloudStrike. You know who I am anyway. It's a computer security concept and practice that gives users limited access rights based on the tasks necessary to do their job. Principle of least privilege ensures that only authorized users whose identity have been verified have the necessary permission to execute jobs within a certain system, application, and data assets and other stuff. Don't use root. Okay, but what about the hard-coded password thing? Also, with that being said, what about the hard-coded username and the hard-coded URL? How do we do that? Well, first of all, you never, ever hard-code any of these strings in a computer program. Instead, what you want to do is to store the values of the values. Well, in this case, username equals root, password equals human horn, and the URL in this case is jdbc :mysql yada yada yada. You want to store that in memory, in a computer's memory. You don't write these hard code in the code. You store the key value pairs in memory on a computer or a server. Yeah, and ThinkOscillator said something called environment variables. So what are environment variables? I'll bring up my terminal here. So if I do every computer, Windows, Mac OS, Linux, has a collection of what they call environment variables. Environment variables are going to be system-wide. What it is system-wide key value pairs that can be used by any application, also including code. So if you do print let's just do a man print env. Print out the environment. Print env utility prints out the names and values of variables in the environment with one name/value pair per line. Okay, so if I do print env on my Mac, it's just going to list all the key value pairs that are listed on my computer. So there is a variable called shell, and the shell I use is bin bash. The user is going to be, well, me. The path, the pwd, if I do pwd right now, my current directory, the documents. But there is a way for setting environment variables, for loading environment variables on your computer. One way is just to modify, like, hold on, how do we set environment variables on Mac OS? Windows instructions are a little bit different. Here we go. How exactly to set up and use environment variables on a Mac? All right. Accept our cookies. Print env. So what you do is you will put all your hard-coded strings, your key value pairs into, well, your certain dot profile, or your whatever your .z profile or your .bash profile. Export, or you can do exactly what a store fee ThinkOscillator. You can also use the export command as well too. Yep, you can see it right here. You can use the export command. So bingo. Export. Okay, so wow, you must have pressed C. You both had mind powers today. So how do you use environment variables in Java? The instructions are pretty similar for any programming language. We use environment variables in Java. Let's take a look. Go to the Twilio blog. Why not? It's system.getEnv. So how you use environment variables in Java is system.getEnv, which getEnv is a function, which takes in one parameter, a string, what the key is. Okay, so this is how you do it in Java. How you get environment variables in Python? here it is. How do I access environment variables in Python? There you go. Import OS. Import OS. Print os.environs. Home. Okay. You can also do an equivalent of print env in Python and print. Use a print function os.environ. Okay. So go back to the code. So we've done how you resolve the hard-coded password, username, and URL issue. Okay. Over importing. Look, don't use asterisk. Just import only the specific classes that you need. So, for example, if you're going to be doing importing prepared statements, so it's going to be import java.sql.prepared statements. So that's that. Need to close a database connection. So what the hell are we going to do with this? Anyone have any idea? Anyone have a good thought about this problem? So you all said correctly that you don't want to just do a system print line of an error message and, God forbid, print the exception. That's bad. Line number 20 is bad. But what is your resolution? What would be a more appropriate thing? Print to a log, exactly. First of all, you never do a system.out.print line. Don't ever do that. The more professional way is this. Either A, print out to, like, send all exceptions to a database of some sort, or better yet, there are also called logging systems. Java logger. Yeah. Logger. Introduction to Java logging. Logger in Java. Let's go to the DigitalOcean tutorial. Okay, what a logger is, it's a system-wide, it's for the entire system, where your whole point of a logger is to log errors. And also other transactions as well too. Java Logger API was in 1.4, and you can use a Java Logger API to log application messages. Application messages can be good or bad. Okay, java.util.logging.logger. There you go. And here are the different types of logging that you can do. Severe, which is the highest. Info, which is info and warning. Info, okay. Info is just, okay, nothing bad. Config issues. Logger.set-level. I'll print that out for you. Yeah, can we just... Do you want to have a conversation about log4j? What is log4j? Log4j is... hold on. What is log4j? Log4j, it's used to record all matters, all activities that go under the hood in a wide range of computer systems. But unfortunately, there was a serious vulnerability with log4j 2 years ago. Yeah, so think oscillator, you win the internet for today, because this was something that no one wants to talk about anymore, because it just brings back horrible memories. And it's still being exploited up to this day. Yeah. So, yeah. So, yes, you do want to send line number 20 to a log, but you want to use log4j. Oh, shudders. Okay, so we're good with the Java example. So the big vulnerabilities were certainly the SQL, the 5-alarm vulnerabilities, hard-coded username and password, SQL injection. Another 5. You can also consider using root over permission. That's also another, like, 4.5, 5-alarmer as well. Yeah, no closing database, not printing out to a log, over importing. These are some of the big ones. All right. Let's now look at example number 2, our friend C. Is actually done, is the username actually done in Java? Wait, hold on. I kept on wondering, like, for name? I think so. Yeah. I think this is the only way you can really log. I think this is the only line number 9. I think this is the only way one of the few ways that you can actually, load up the driver. I think. Hold on. Let me see. How do you properly load up? How do you properly load JDBC driver? I am told the preferred, here it is. The preferred method to load the JDBC driver is class 4 name, driver name. Interesting. Runs the static initializers. Oh, okay. I just post that here. Why is it censoring out stuff like that? They can't censor out ass, but they can censor out the other part of ass? Really? I don't know. Okay. Anyway, let's move on. Oh, geez, 5 o'clock already. Alright, there you go. There is a C program here. Where's the vulnerability? Or what is it? Actually, just print out here. Here's the question. The real question is, where is the vulnerability? What line number? 16. Anyone else? Okay, the question I asked is not what the vulnerability is, but where. Anyone else? Anyone else? Cool fam, bingo. ZR_Jumbo. Who taught you stir copy? Okay, here's my fun question I asked you before. Okay, who taught you that there is a vulnerability in stir copy ZR_Jumbo? And who taught you a stall fee that it should be stern copy? I'm very curious. ZR_Jumbo and A_stall_fee. Who taught you that the vulnerability is stir copy? Who? Maybe the million times my program crashed from self. Okay. I'm very saddened that no one really, I mean, it still bothers me. ZR_Jumbo and A_stall_fee. Yep. Don't remember, but if argv, okay, so here's the, okay, let's take a look at the code again. Stir copy just assumed that the DST buffer, who taught you that though? I'm really curious. Or did you learn it on your own? Or did you burn yourself too many times at the stove? And then you finally learned. I'm actually wondering. So ZR_Jumbo says, yeah, you're oh, okay. But you didn't do your undergrad at Tufts, did you? I don't think you did. Okay, so but if argv is longer than buffer_2, then it overwrites a null character. Okay. So the vulnerability really is, yeah, you learned on a YouTube video. I got a copy of it in like 1993. Okay, so I'm gonna run this program. Before we talk about what and where, or like why, let's talk about the where and why. Okay, so you're gonna argue stir copy, but let me just illustrate what's wrong. Yes, KNR is a classic that everyone should, any developer should have. So I'm gonna go GCC -O vuln von.c. That's more von.c, by the way, just to let you know that it's the same stuff, the same code that you see here. It's the same one. Yeah, I just do a compilation again. Here it is. So now I'm going to run. If I actually just do .von, so it needs to take in user inputs. You take a look at from the source code, the initial value, the initial value of initial value of the value variable is 5. There are two arrays, buffer underscore 1 and buffer underscore 2. They initially will have the string 1 and 2 respectively. But then it's going to print out the initial values of buffer underscore 1, buffer underscore 2, and value. And then this is where things get really messed up, is going to be copying whatever you got, whatever you type in into argv1 into buffer underscore 2. You ready? So if I'm going to do .von, I type in a lowercase letter A. Alright, so it works. Buffer underscore 2 is at memory address and contains a string 2. Buffer underscore 1 is at, well, that memory address and contains a string 1. The value value is at memory address and is number 5. Alright, so we copied 1 byte into buffer underscore 2, which will contain an A. Nothing's wrong with buffer underscore 1, value is still 5. So far, so good. Alright, that's it 2 ways. Alright, so far so good, looking good, looking good, looking good. Let's do 3 A's. Alright, looking good, looking good, looking good, looking real good, looking real good. 4 A's. Okay, looking good, looking good, looking real good. Nothing wrong, nothing wrong. 5 A's, still looking good. 6 A's, alright, nothing wrong, nothing wrong, nothing wrong. 7 A's, nothing wrong, nothing wrong, nothing wrong, nothing wrong. 8 A's. Uh-oh. Now things get really messed up. Let's do another 9 A's and, oh dear, 10 A's. What the? 11 A's, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 A's. Oh shoot. Oh no. And now we're not only overwriting buffer underscore 1, but also value as well too. And now we got a sick fault. Alright. So what is the name of this vulnerability? Anyone know? Actually, it's not stir copy. It's not just stir copy. Okay, so what is this vulnerability called? There's a formal name for this. Fury. Hey, Fury, how are ya? Pretty cool farmer. Here it is. Out of bound right, 787. Number 1, CWE-787. The product writes data past the end or the beginning of an intended buffer. Memory corruption. This is also known as a buffer overflow. Okay? Out of bound write, invalid write, buffer overrun, buffer overflow. They're all the same thing. Yeah. It's also known as a buffer overflow. Here it is. There's a whole bunch of examples here. This is CWE-787. Alright. So now we know, well, you saw with your own eyes, this is exactly an out-of-bound write. But where's the root cause? The root cause really is, as you all pointed out, is the problem with stir copy. Furthermore, some people will make a strong argument that it's also a C programming language big problem as well too. What stir copy is copying, data from, usually string copy from one end to the other. But here's the real explanation. Why is that a problem? Why is stir copy the problem? Well, here you go, folks. I'll give you this document. As my friend and mentor Gary McGraw says, these are what you call the dirtiest of the dirty functions. Common vulnerabilities guide for C programmers. Most vulnerabilities in C are related to buffer overflow, and here's the reason why. There's no bounds checking in C. Okay? Most vulnerabilities in C are related to buffer overflow and string manipulation. In most cases, this would result in a segmentation fault, which you just saw, but specifically crafted malicious input values adapted to the architecture environment could yield arbitrary code execution. You will find a list of the most common errors, suggested fixes, and solution. Anyone ever use gets or gets? The standard input output library function getS function does not check for buffer length and always results in a vulnerability. Vulnerable code. Okay. And the mitigation is prefer using fgets and dynamically allocated memory. Stir copy. Here we go. The stir copy built-in function does not check buffer length and may very well overwrite memory zone contingent to the intended destination. In fact, the whole family of functions is similarly very vulnerable. Stir copy, stir cat, stir compare. Okay? So here's vulnerable code. I should have just saw one moments ago. The mitigation. The best way to mitigate this issue is to use strlcopy if it is readily available, which is only the case on BSD systems like macOS. However, it is simple to define it yourself as shown below. So basically stir copy with a length check. Okay? Another and maybe slightly less convenient way is to use stern copy, which prevents buffer overflow but does not guarantee no termination. Stern copy also have a buffer size as well to length check. sprintf, just as previous function, sprintf does not check the buffer boundaries and is vulnerable to overflows. Alright. Now also if you actually in modern like systems like Mac OS, if you try to compile vuln.c, it will actually give you a big warning saying, well, you're using stir copy because it doesn't have any length check. So really the root cause is the use of the stir copy function. Okay, because stir copy does not have any built-in length check. So further question, and this will get into a flame war, someone will also argue, is it safer to use Rust? Is it better to use Rust or Java? Over C? Is it better to use Java or Rust over C programming language? I remembered when I learned software security with Gary McGraw. He was very adamant. Yes, Java is safer than using the C, and that led to a complete flame war, which we actually still have up to this day. Some people will argue that, but it's like C, programming language is any programming language. You just have to be mindful and you have to know what the hell you're doing. That basically and exactly. It's so long as you stay away from the unsafe function. Furthermore, I am going to make this comment right now. I'm just extremely disappointed in computer science programs. I don't care where it is, not only at Tufts, but also anywhere, that they never teach that. Very, very few institutions actually even just inform students that function like stir copies are really bad. I mean, here's the thing: is that if you do a search for stir copy on even at C++, yeah, I mean they yeah, I mean, come on. You go to Microsoft document. Here it is. Copies a string. Look at that. Here it is. Even the Microsoft documents makes it very clear. More secure versions of these functions are available. See stir copy underscore s, wcs copy dot underscore s, and mbs cpy underscore s. There you go. Well, marks. Yeah, look at that. Because stir copy does not check for sufficient space before copy has a potential cause buffer over one. Therefore, we recommend you to use stir copy underscore s instead. Look at that. So now you learned about the dirtiest of the dirty. Let's see. Alright, we'll do the final example. JavaScript. What's the vulnerability? This is a server. Alright. I think Osculate see eval. Alright, think Osculate pointed out is eval. Eval Homer. Alright, I'll do one better. Server 35.194.6.104. Right now, okay, so I'm going to tell you the port number to use is for port 3000. Take a look at this code. You know what I'm going to do? I'm going to run it. Node server.js. Okay? What I want you to do is shut down the server. Take a look at the code again. I'll let this on the right of on the left of my screen, but take a look at the code. I'm telling you right now that the IP address of the server, I'm running an instance of server.js on 35.194.6.104 port 3000. I want you to shut down the server. You should be able to do this using a command line. Shut down the server. I'm actually going to open up a brand new terminal myself. I'm local on this is my local terminal right now. This dev is at 35.194.6.104. I want you to shut down the server. So if I do curl minus data, minus data do post. Oh, port 3000 as well. Yeah, I hit Control C. But I want you to shut down the server. Like, shut the damn thing down. Now, by the way, whenever you okay. Now, I saw a couple of imports. Alright, and then you have to shut down the server. Shut it down from running. Almost. So the caveat is this. It's looking for some data, any post data. So anything that you send to the server is going to be evaluated. How the hell did you get path? Interesting. Close. What if I did this? Close. What if you did this? I am going to feed to the server some data. What if I did console.log a stall fee was here? Ooh. Nah, that's not gonna work. Good luck. I need you to shut down the server. Oh, I had to Control C. But what happened if I did this? You see there's a request response here. Can I print JavaScript objects out? Yeah, sure. Woo! Can I print a math object? Ah, I can. Interesting. So all you have to do is to quit the, okay, so as you can see, whatever you are sending to the server is the server code, line number 12, is trying to, oh, you're so close. Oh, you're so close. So close. Whoever typed in process.exit. So close. I'm not doing it. I mean, whoever typed in process.exit1 is like that close, within like a millimeter. No. Here's a hint. What if you actually do process.exit? I want someone to do this. It's probably that. Okay, what happened? You don't do a semicolon. What happened? You removed a semicolon. Bang. Whoever did that. Nice. Well done. Well done. Whoever did that, thanks. Yeah, so semicolon can throw you off in this case. But yeah. Look. So that was cool. That was really cool. First time I've ever done something like that. So what's the point here? So what's the point of this exercise? It's just really to illustrate line number 12, the problem with eval. Alright, JavaScript eval. Now I'm going to show you every single programming language has an eval function built in. Let's take a look at the JavaScript version. Let's take a look at what the JavaScript doc of eval says. The eval function evaluates JavaScript code represented as a string and returns as completion value. The source is parsed as a script. There it is. Here's some examples. Again, what eval does is evaluate a string as code. But notice that in JavaScript, executing JavaScript from a string is an enormous security risk. It is far too easy for a bad actor to run arbitrary code when you use eval. See, never use eval below. There you go. Basically, eval is evil. PHP eval. Actually, hold on. Let me just copy this off a minute, print it out. Really, today's session could be called eval is evil. PHP eval. Again, evaluate the string as PHP code. And here's a caution. The eval language construct is very dangerous because it allows for an execution of arbitrary PHP code. It is used as therefore discouraged. Alright? Python eval. I'm not going to go bad mouthing. Here it is. Eval. They don't give any security stuff here. Ruby eval. When is eval unjustified? There you go. Is eval supposed to be nasty? And fired I this. I've been using eval feature for Ruby many times, but I've been using it. Yeah. Problem is analogous to SQL injection. Yeah, the early JSON parsing was, yeah, that's true. The original JSON parser, I think it's still, I'm not sure if it does, still uses eval. The whole point of this exercise is, of this JavaScript example, don't use eval. Okay? What's eval JSON? I think that's still like the only justification. All right. So we did a JavaScript bad code, Java bad code, and C bad code. But if you take a look at like each and every one of these examples I posted that I actually showed today, Java and C. Okay, to make a long story short, in C, stir copy is bad. Java, you have SQL injection, hard-coded password, and a whole list of other stuff. And of course, in this JavaScript code is eval. So what's the point here? Now, with the exception of the Java test, we didn't even need to execute and run this Java example to pinpoint the vulnerabilities. We did run the C example and the JavaScript example. We did run them. But really, quite frankly, you all pointed out the vulnerabilities without even running the code. Alright? If it's so terrible, why the programming language is included? That's a good question. Yeah, is there a... Okay, here it is, JavaScript. Why does it exist? Most programmers say it's bad practice use the eval function. Here it is, yada yada yada. So why does it exist in the first place? It's a good question. Because sometimes there is a need. There you go, Flocka. There's your answer. Because sometimes there is a need. Because sometimes there is a need. That's it. Because sometimes there is a need. That's it. But anyway, going back, for example, so what's the point of doing these 3 bad code exercises? Well, the point number 1 is to inform you. Again, to my dismay, most computer science programs, boot camps, education does not tell you if you're doing C programming that strcpy is bad. Same thing with hard coding username and password, we're still dealing with today. And about eval. So that's point number 1. I mean, the reason why I want to have point number 1 is to inform you of bad programming practices and what you really don't want to do to make things even worse. That's point number 1. But point number 2 is maybe it's a good time to use static analysis tools. Okay. So, if you like software development, if you like to build software, and you like to build software, something that is in your arsenal that you got to use is what they call static analysis. All right, I'm going to open up a brand new file. Actually, I'm going to create a new file, static analysis. Static analysis tools. All right. What the hell are we talking about here? What's static analysis? Think of it this way. Code scanning. Okay? No execution of code or program. For those 3 those 3 source code examples, the C program, JavaScript, we could have used a static analysis tool, and it will probably pinpoint the vulnerabilities just like that. Static analysis, no execution of code or program. Okay, use on source code. Use given source code or binary. What? Really? Wait a minute. You can use static analysis on binary code, like binaries? The answer is yes. Remember, you can always reverse engineer binary program into its code form in some way, shape, or form. Maybe not perfect, but a good chunk of it. Okay? The one beautiful thing about static analysis tools, it will always have 100% code coverage. Even the unreachable areas of a programmer code, a static analysis tool will find vulnerabilities. The big problem of using static analysis, the really big problem is, can generate lots of false positives. Okay, that's one of the biggest problems with static analysis tools. Static analysis tools often give back a lot of false positives and stuff that you don't care about. Okay, here's a plus or a minus. It's a good and a bad thing. Lots of options. Free and commercial tools. Okay. Oh, another big negative. Cannot find configuration issues. If you have If you're dealing with configuration, yeah, static analysis will not find them. Static analysis is really useful for scanning code that include binaries for vulnerabilities and issues. Okay, and generally can pretty damn good result. Examples. The quintessential static analysis tool, which is every single programming language has this, is called lint. Linting. Okay, so let's look at there's something called PyLint. Via Python, it's PyLint. PyLint is a static code analyzer for Python 203. And so how you use PyLint is actually you can build it into your Visual Studio Code. How do you use PyLint? Pylint.org. All right. Oh, okay. So what about JavaScript lint? JS lint. There you go. Here's JavaScript lint, static analyzer. So, check a look. This source code example, unexpected eval. Okay. What about, I'll just feed in my crap here. Copy all this. Go to jslint.com, paste this mess in. Hit the button, linting. Undeclared required. Use double quote, not single quote. Okay. Hey, use space, not tabs. Use space, not tabs. Again, really makes my point clear about a lot of false positive and stuff that you don't care about. Yes, some hardcore developers will have a problem using tabs. I know some of you folks have tab. I'm sorry and not sorry at the same time. Undeclared console. Expected and, oh, interesting. Unexpected eval, alright. And a whole bunch of other things. So this is JSLint. There's also PyLint, there's also CLint. The CLint is the most famous one. If you're going to be using Android Studio, has a Java linter already built in. In fact, most Visual Studio, the full Visual Studio, already has a static analyzer for you. Alright, so an option is to use lint. Another option is this. There's a whole bunch of static analysis tools out there. Anyone use like Ruby? Yeah. If you're actually doing Ruby programming language, there's something called Sorbet. That's built by Stripe. Anyone here taking CS 105 programming languages at Tufts? Anyone? Do you remember the thing called the type checker? Cool font, yep. So Explorer 88, do you remember something called the type checker? The type checker is a very good example of, okay, actually I'll come back to this one a little bit later. Flow, static type checker for JavaScript, okay? So a type checker is an example of a static analysis tool. So why is type checking important? Does type checking support, give security vulnerabilities? And the answer is, you bet it does. I'll give you a really good example that I experienced quite a bit. So have you ever, are you familiar with something called latitude and longitudes? For geolocation? So if you're doing geolocation, what's the data? What should be the data type of a latitude and longitude? What's the data type? Latitude, longitude, data type only. Anyone? Float, perfect. So it's either floating point number or it's a floating point number. Perfect. Have you ever used Google Maps before? More specifically, ever used a web page using the Google Maps API? So here's the thing. The Google Maps API specifically says when you use Google Maps, latitude and longitude must be floating point numbers. Has to be floating point numbers. Else the map will crash. I can't tell you how many students I have seen over the years, and even after warning them that you store latitude and longitude as float, not strings. That you got to do a conversion because everything that you send from a web form or a web is string based. Many people's Google Maps crash because, they forgot to do that one step, which is to convert string to float. So they store latitude and longitude into a database as a string, and then when they try to use the latitude and longitude in Google Maps, it doesn't work. That's the vulnerability. Yeah, that's the problem. That's why type checking is so important for not only programming but also for security as well too. Here's Flow. I think Flow was built by Facebook. Yes, it was. Flow is a static type checker for JavaScript. Tired of having have to run your code to find bugs? Flow identifies problem as you code. Stop wasting your time. Yes. Okay. A little smarter. And here you go. A little bigger. Get started. Oh, look at that. Flow's a static type checker for your JavaScript code. It does a lot of work to make your code more productive. Makes your code faster, smarter, and confidential to bigger scale. There you go. Okay, so that's one example of static analysis. Another one, they also built something called, Facebook also built something called Infer. This one's a pain in the ass to use and install. Infer is a static analysis tool. If you give Infer some Java or C++ Objective-C code, it produces a list of potential bugs. The keyword is potential bugs. Anyone can use Infer to intercept critical bugs before they have shipped to users and help prevent crashes or poor performance. It's used namely, especially for Android and Java, for null pointer exception, resource leaks, and all this other good stuff. Null pointer dereferences, and here you go. I'll just show you the video of how this works. Yeah. Alright, no issues found, but we're going to make a change now. They're going to make a change, which is it may cause null pointer exception. Ooh. Boom. No reference pro. Okay. Anyone of you something on GitHub? GitHub also has code scanning now. Nice. You can use code scanning to find security vulnerabilities and errors in your code for your project in GitHub. Okay. Very important. How about this one? Now, a lot of students use this for the capture the flag because remember I gave the entire source code of the capture the flag game. A lot of students I've seen last semester use SYNK. Secure your code with static application. Code security with a developer-friendly experience. Back in the heydays, for years, I was given Veracode, based in Burlington, Massachusetts. Thousands of dollars to use. And the actually is, hold on, I'll show you. Yeah, here's an old report. Veracode. Veracode is proprietary. Is not free. They have a static analysis tool. What's nice about their Veracode binary static analysis tool, it can actually do source code or binary. You can upload either one. find flaws at an accurate scale. Okay, so I'll show you how a Veracode report looks like. It's really nice. Actually, I think this is publicly available anyway. Yep, here it is. Here's a Veracode report. Application security report. There it is. So a former student actually wrote a bot, a Facebook follower counter bot in Python in 2017. Uploaded her source code, her entire project to Veracode. This report contains security flaws identified in an application with automated static and automated dynamic scanning techniques. There's an executive summary. Summary of flaws found by severity. Here's the scope. Static analysis can pinpoint exact where the vulnerability is, but it can't prove. Alright. Here it is, flaws. Code injection, cross-site scripting, cryptographic issue, directory traversal, server configuration issues. Oh yeah. So here it is, code injection. Code injection is the process of injecting untrusted input, yada yada yada, CWE ID, and a location, launch.py line 30 and 31. That's where the vulnerabilities are. Okay. There's a whole bunch. So yeah, I mean, the static analysis tool from Veracode found potential vulnerabilities in the source code, but it doesn't do a proof. It doesn't do the actual exploitation. Okay, so the whole gist, one of the big important points is if you want to legally cheat in the current lab number 9, which is a technical risk analysis, currently available. You can legally cheat on lab number 9, technical risk analysis. Now, here's the thing. Please, for those of you who are doing this lab, I give the entire CTF source code. But for the love of God, please take a moment to actually look at the source code, especially the important files like board.php, with your own eyes. Just gloss over it. You don't need to read line by line, just gloss over the code. You may be able to find 1 or 2 vulnerabilities. Okay? But you can legally cheat on this lab, okay, because there is an extra credit, which is to create and run a static analysis scan of either the capture the flags game or any application of your choice. Oh shoot, I have to change the rules here. These rules are a little bit different. I know why I put this one in there. The instructions are wrong here. The canvas instructions are more up to date. This is wrong now. But I was working with a certain agency with this about this lab. Back in the heydays, Veracode actually gave me a free subscription to Veracode for the entire year, but they no longer do that, so it's a pain in the ass. Sorry about that, folks. But yeah, you can legally cheat on this lab by doing a static analysis scan of the entire CTF game file here. Use the findings and build your report, build your report and table that way. But really, seriously, even before you do that, just take a visual gloss at the source code, like on board.php or the schoolboardindex.html files, and find like you can just eyeball. You may be able to eyeball vulnerabilities that were not in the game. Really quickly, there's also the complete opposite. I'll just mention here is their static analysis. This list goes on. It's also dynamic analysis. Dynamic analysis, runtime. Okay. Static analysis, no code execution or program. Dynamic analysis is the complete opposite, which is runtime. Execution of code can help determine runtime and configuration issues. Okay. Obviously, the biggest problem is no 100% code coverage. This makes sense because if it's going to be checking for a runtime there's maybe parts of an application that can't be reached, so it won't actually find any problems there. Okay, but here's a fun question before we the one way that we end. Does anyone know of a quintessential dynamic analysis tool? Really, one tool should come to mind immediately when you hear of dynamic analysis. A dynamic analysis tool, it runs at one time. Anyone else? Hey, Avocado, Cool Farmer, do they still, so for those of you who have taken data structure, the intro to CS, and CS40, the architectures course at Tufts, do they use Valgrind in all three courses? Valgrind. Yeah, Valgrind. What Valgrind is an instrumentation for building dynamic analysis tool. Really, the real good part of the use of Valgrind is to detect like memory leaks and memory issues. Okay? Yeah. All right. Do they even use Valgrind in 11 in the Intro to CS course now? Yeah, Valgrind. I remember. You know who was responsible? You know who was responsible for introducing Valgrind in CS40, right? Anyone want to take a guess? Who was responsible for introducing Valgrind to Tough CS? So actually, I'll go one step further. I'll also ask a following question. Who is responsible for introducing Valgrind to the data structures course? Anyone want to take a guess? Yeah, I heard there's problems installing Valgrind on a Mac. Okay, so it was Norman Ramsey who is the father of both CS40 and 105. He introduced using Valgrind first time around. So it was Norman who started the use of Valgrind when he first came to Tufts in like 2000, early in the mid 2000s. And when he created what is now CS40, he introduced Valgrind. He required Valgrind. Believe it or not, then in 2011, I taught data structures. No one died. Everyone survived. It was like a really big roller coaster ride. But it was me who introduced the use of Valgrind in data structures, which still happens up to this day. Yeah. So now you know a little brief history of the use of Valgrind at Tufts. Norman used it in 40, and then a few years when I started teaching 15, because for years the jump from the intro course and data structures to 40 was just an abyss. It was just really bad. So yeah, so I introduced the use of Valgrind in data structures. So we're done, folks. But one last thing. Do you need to know the terms dynamic and static analysis? Oh yeah. Why? All leads up to one last topic. What do you think the one last topic is next week? Everything leads to one last topic. Will you see dynamic and static analysis again? You bet. Take a guess what the last final topic of the course is. All roads, everything that we have done in the course lead to one last thing. Oh yeah, Xcode contained unit tests. The one last thing, everything in this course leads to one last thing. Anyone? Anyone want to get a guess? Mm-hmm. As Explorer 88 says, malware. There's a reason why I designed this course this way. From networking, attacking networks, PCAPs, crypto, web security, vulnerabilities, and now static and dynamic analysis. Everything leads up to malware. Thanks all. See you next week. We talk about malware.